Hey everyone. So today we're going to be talking about building versus buying, and it's like a dilemma that we have on the company in case that we would buy an SCA or we would build one from scratch. And then we actually end up building one, and we ended up doing a development in-house for an SCA tool, which is kind of not the usual thing, as you will kind of understand that we are a kind of large-scale organization, and the goal normally used to be to go ahead and just buy the tools itself. But well, this was a funny opportunity, and we're gonna talk you and tell a story about it. So first of all, my name is Diogo. I am from Portugal, as well as my colleague over here. I'm a security engineer. I've been working with security for around 5 years. I actually started my journey building security products at Checkmarks, then kind of wanted to implement those security products and moved to a company named Flutter Entertainment, where I had the opportunity to pick up those security products and implement them in the real world. But well, I actually started and keep on doing and building security products where I was. And well, last month I actually changed jobs for another company, a couple double X, and let's see how it goes.
So on my side, my name is Fábio Pinto. I forgot to change the title, otherwise I could have my name in there. I'm a security engineer. I work at Flutter UK&I for around 8 years. Actually, it was my first job. But the betting companies are quite challenging in terms of security. There's no boring work at all. We keep having more challenges every day, so that's the reason why I keep working there and being happy with it. Now I will pass the baton to Diogo, and he will talk to you a little bit about our agenda and the SCA.
So this will be starting and keep going on 6 different things. The first one would be for us to introduce what is SCA, then what we did to tackle the issue itself, the solution that we use, and the things that we use to make up our solution, then some of the little key features that we have. We're going to do a solution walkthrough and then a real demo. With live demo, everything would go beautiful well in there. And then we go say some key takeaways and future vision for the project. So we're going to start introduction to SCA. And for those that doesn't know, SCA is like a process that involves you identifying and analyzing the open source and third-party components in the software code base. And it's like you have several components in your application, and you kind of will check up on those components. It's basically, in a nutshell, checking if those dependencies that you are using in your project have vulnerabilities or not. And that's SCA for it. But why in the end, the thing is SCA important in modern software development? Because nowadays, applications just often rely on multiple code base and multiple open source libraries. And even if those libraries are not like a must-have, they are just convenient tools and essential parts of the code base itself. But like everything else that is a lot of funny and a lot of simple to do, it also carries a little bit of security risks. And well, that's why it became a critical problem, because you have issues, you have in the end 3 main topics, which is transitive dependencies, which in the end you install a dependency, but that dependency itself uses other libraries. And the developers may not know the full chain of dependencies, and it makes it harder to track vulnerabilities. But also you have dependency detection issues, because you have a dependency deep down in your code that you installed like 3 or 4 years ago, and you don't even remember that it's there. But well, you never uninstalled it, it's there, you don't even know it's there. You have like a big application, it's just there deep somehow, and it might be vulnerable, and you don't even know that you are still using that dependency. And then it's scaling the issue, because I think it's a little bit easier if you are like, you only have one application and you are tracking the vulnerability itself. But when you go to a large-scale organization and you have like thousands of applications, you have things that runs all the time, everything keeps on moving, keeps on changing, and you need some kind of process, an automated process more or less, to have it scaling at the pace that you need. And when we get to the real issue of the question, which is managing those dependencies in modern development, because the developers often use package managers like pip or npm to install those dependencies. It's like a thing that they will keep on using. It's simple, it's practical, it's a good thing when we are doing development. and they may not be aware of all the dependencies that come with those backend managers. Like, you can be installing a simple dependency, and that dependency brings a lot of things that are vulnerable, but you don't even know it because you are just installing one. Well, that's an issue, and because in the end, when you install some kind of dependency, it brings both direct dependencies and transitive dependencies, like I've talked about, and it's like a dependency hell. A developer just keep on testing one thing, testing another one. They will just do npm install to everything. They will bringing everything into the code. The things will be there. You will never manage it. It will be there for years, until at least you do a kind of big refactor or just delete the application itself. Otherwise, the applications and the dependencies will keep on being there. And I guess the issue itself is you don't even know what's there most of the times. It's just on the node models, on the requirements, and you keep adding and adding and adding, and but that's how it is. And it's like, you have challenge, because you can just go do an npm audit or just do a pip freeze and get the list of dependencies. But like I said in previously, that works if you have small applications. If you have one node models, you only have one application, you'll kind of be tracking and inventorying those things. But when you get to the real world, to a large-scale organization, you kind of need to have like a proactively way of finding those vulnerabilities and those dependencies. And you need a process to do it. So we kind of know the issue right now. We know there's an issue on managing those dependencies in modern development. We kind of need a solution for that. So we kind of, let's put it out topics that we need when we are trying to find and developing a solution. And the first thing, we kind of need to have an inventory of dependencies, so we can see what dependencies are in which projects, in which repos, and then maybe go there and do something with it. We actually need to track the versions itself, because like everything, one version might be vulnerable, but others might not be vulnerable. So you just don't need to just keep on installing the latest dependency on everything, because you're kind of not needing it. And also, most of the time, upgrading a dependency also involves that the developers go into code and maybe check if the dependencies are working, and that takes time. So if you keep at least a track of our dependencies, we can just improve whatever we kind of need. The other thing is we kind of need to automate the vulnerability detection, because otherwise we'll just be importing the vulnerabilities once and keep on there. But well, new vulnerabilities come up every day, so we need to have some kind of synchronizing thing that gets all the vulnerabilities every day and synchronize with our space. And we also need some kind of provide fix and remediation, because one of the things that we noticed when we first developed the first phase of the project is, unless you have like a really good UI and UX, the developers won't use the tool. And when you have like thousands and thousands of vulnerabilities, you kind of need to have some kind of tool to help the developers go into there and fix their own things. Otherwise, they will just say, okay, we don't know, and because it's a lot of things, they won't be fixing like 100 vulnerabilities. They need to have some kind of automation to help them doing it. And if you have like a button that you can just click on and say, okay, just renovate all to the latest that is not vulnerable at all. Okay, they will click the button and it will take their time to approve and check if everything is okay, but at least you take a lot of work from them side, and well, I think that works a little bit more. And you have to have like some kind of synchronization and continuous monitoring, because you need to keep on adding the newest version of the code with the newest dependencies. Because okay, you have a commit of a branch, you have a commit of a certain repo, but you need to keep on scanning the newest and newest and newest. Otherwise, you'll just be guessing that you have a vulnerability that might not be already on there. And well, you need to do something about it. And then the last one is like you need to have a place that developers can go into and then see what vulnerabilities they have, see whatever in there. You like create dashboards, create a scoring for it. You need to have a place that then developers can go and triage the issues itself. So now we understand the problem itself. We understand what we want in a solution. We kind of need to have a solution that goes ahead and helps us doing the SCA, because when we were on the company itself, most of the times that we have a new instance saying that vulnerability is vulnerable. So a dependency is vulnerable. We need to do something about it. And well, the best way to do it and improve it is to have like some kind of mechanism and some tool to tackle the issue itself. And well, what we need, if we take our company in the mind, to get an SCA tool that works for us. One thing that we need is an inventory of components. That's thing. We need to have a single place where we have all the dependencies. We need to kind of know what components are vulnerable, otherwise just be a list of dependencies. We kind of, in our organization, need to have coverage for multiple code bases, as we have code on GitHub, GitLab, Stash, and all of that. We kind of need to have a solution that covers all of that. And we kind of need to have a real synchronization and visibility of the vulnerabilities somewhere and some place that does the work for us. And well, we went on the market. We kind of check a lot of solutions. Some were good, some were bad, some were pretty much expensive. And it's like a thing. You're gonna pay for a solution that it's very expensive, and you think like, will it be worth it? Will it not be worth it? And well, some of them have like limited code base, only support GitHub, others only support GitLab, and we kind of need a solution that goes everywhere. Some had poor UX and UI, so if you don't deliver a solution with good UI, the developers won't go into there, so we need one of those. Some had no customization, and we kind of need customization because in a large-scale organization, our issues might not be the issues of another company. Everything got its own things. So you kind of need to track your own issues in a different way from another company. You need to have your own things. And well, we needed some kind of flexibility on that. So we kind of need of a tailored solution for us, which was like cost efficiency. And well, that's what we went for it. And when we were developing an SCA tool, and not developing, when we were checking the other SCA tools, we kind of noticed that they all kind of work at the same way. We kind of need to have an SBOM, which is a software bill of materials that tracks everything that is in your application. That's the focal point of an SCA. You kind of need to have a dependency database. That's a second point. The third point is to have a place where you can show and triage and do everything with those data that you get from the results. And like the fourth point is not that important, and it's not required for an SCA tool. But we kind of see that the solutions on the market are quite expensive. Building an SCA might not be that difficult to do it. And we were like, okay, maybe we can do something in-house that it's pretty cool, and then it would be a challenge for us. Because you are a security engineer, you kind of use tools from the market, but if you can build something your own, that might be even a funny way to do something and start building some tools for the open source and for the community. And well, that was a pretty good opportunity for us.
So now I'll jump in and I'll talk you guys about the solution itself. This solution was built 100% on top of open source tools. Those tools are OWASP like on the X, where you will see the XGen to generate SBOMs, the bill of materials that we'll be using for this demo. OSB.dev is a vulnerability database that is provided from Google, where you guys can check for the dependencies and their vulnerabilities. It also can consume an entire SBOM at the same time. This is what we are doing. We are not checking for each vulnerability in the API. We are passing the entire software bill of materials of an application, and it's returning the data back with all the vulnerabilities for those components based on component and version. Another thing that we check on a daily basis is for end-of-life dependencies. End-of-life dependencies are a problem, and we check for those. We will not have end-of-life dependencies to show in this demo because the job takes a little bit more to run. It takes like hours to run in the end, and basically it needs to run after we do all the process and have everything set up. And then data processing and display, and this is where I will talk you guys a little bit of Surface Security. So Surface Security is our open source platform, is an organization in GitHub where it's a Django Python-based platform where we are syncing and correlating a lot of data in-house. This started for DNS coverage back in 2010 because it's hard in a big company. It's hard to get full overview on your DNS. We started with this, and after that we start building small modules to put in the tool and to make it bigger and bigger and bigger. So it uses Django, uses the cron. We use Grafana for the dashboards. Ansible, Elasticsearch, and our database is MySQL at this point. It also supports Postgres, so you can integrate as any Django application. You can choose between Postgres or MySQL. So what was the process? Diogo described this already a bit, but we create a software bill of materials. So there's a big JSON with all the information about dependencies. And okay, now I know for one application which dependencies I use. Nice. So after that, now how can I check the vulnerability? So we run the SBOM against osv.dev, and it brings back the vulnerabilities. After this, we push all the results to our platform, Surface. And on top of that, this was the process I was describing before. We check for the end-of-life dependencies, and we have views to check the vulnerabilities and also, of course, the dependencies. Because building a dependency tree is not so easy after you have all dependencies, for example, in a pip freeze. And we can do that using the SBOM to build that. So identifying and processing dependencies, synchronizing SBOMs, managing vulnerabilities, and custom dashboards, because we need the developers to use this. If you build something, the idea of this tool was entirely to work as a self-managed by the development teams. This is now your responsibility. We gave you the solution. Look into your code and update your dependencies, because we cannot cover the code base for an entire company, of course. So how does it work in our case? We use Jenkins and GitHub Actions to generate the bill of materials. We also reused our SaaS jobs that were running in Jenkins, because for some projects, we need to actually compile the project before to generate a bill of materials. And then we push all the bill of materials to Surface on a specific module that I will present, that is the SBOM repo. It's just a repository where we store all the software bill of materials that we are being scanning. Then we have the OSV-dev, as I described. So we get the data into there, we cross with OSV-dev, and then we sync the vulnerability data. And on security surface, we have the UI, the reports, the score. The score is a process that we are not presenting here, but is something that we implemented inside the company that is a way for the teams to know their security posture. For a specific vulnerability, based on criticality, we give a weight, and then with the sum of weights, the teams know the security score for their application, so they know where to focus from a security point of view. So the key features and advanced capabilities are the ones that I mentioned: synchronization, dependency processing, project grouping. This is an hard one. I will show you in the demo the difference between synchronizing things into a project or not, and the management of vulnerabilities. The extra features that we did on top of this, it was custom views. We needed custom views because it's really important to have custom views. Automatic updates. Okay, we give the developers information that they have this specific vulnerability on this specific dependency, but then it's up to them to go and search for the fixed dependency to put in their code. And this is not, when you have thousands of dependencies, it's not so easy to manage. So we provided the ability of, with a single button, to basically upgrade your dependency on a minor version or on a major version. And then the merge request will be created on the developer side, and they will manage it as another code integration. They can compile their code, they can see if it breaks anything. If not, they can merge it, and they have an updated dependency. Of course, yesterday we talked about SAST here, DAST, and false positives are a reality. In this case, it's not about false positives, it's mainly about vulnerabilities that doesn't make sense in your infrastructure. Because you can be vulnerable to something that actually is not a vulnerability from the outside, because you have a lot of controls in there, and the way that your services work make you not being vulnerability to that specific case. Integration with CI/CD, this is an important one. We have this process where we block pipelines based on security. Yeah, our developers hate us. because if your code doesn't meet the standards we defined in the company from a security perspective, we'll basically block your deploy, and then you need to fix those things before you go to production. Of course, there are workarounds for incident development driven things, but this is happening, this is in there. This was something that we fight for a lot of years to be able to implement, because in a company so big as in the gaming industries, product is key. Product is the first thing that we care. It's new functionalities over security. And this is something that we need to fight against every day even more. And of course, there are vulnerabilities that don't yet have a fix out there. So we need a way to identify and for developers to know there is this vulnerability in your code, but there's no fix yet for it. And this is really important for this. So in this part, I will talk to you a little bit about the main modules, and I'll try to give you a real-time demo of the product working. So the main modules of this are the Surface SCA, that is a module inside of Surface Security, and Django SBOM repo. This is basically Python package. It's a Django application also. It's a Python package that you can put on top of any of your Django applications if you run one, or you can run one from scratch and install it, or just run it as it is. So Surface SCA, this is the view I will be showing after. That's the repo, Surface Security Surface. And Django SBOM repo is basically our repository database where we store the software bill of materials for all the applications. It's basically an API. There's no UI on there. It stores it, and then Surface will consume the data from there. So let's go to the demo. Let's pray to the demo gods. I think I set it up okay. After yesterday's problems with the Google release, but we are fine. And let me show you the face of the open source version of Surface. This is really small. It has a lot of integrations already open source, but inside the company we have much, much more, because we are building on a daily basis on top of this, and this became the core tool for our security teams. So as you can see, I'll just show you that we don't have any dependencies for now. We don't have any project. We don't have any a vulnerability itself, and nothing is suppressed for now. On the other end, this is the API for SBOM repo, and if I just run it, there's nothing on it, returning the SBOM, so the database is completely clean. And another end, because we talked about self-auto-remediation with a single button, there's no pull request open in this repository. So now, I'll go to our terminal. We'll have, at the top right, just a shell where we will execute commands to push the bill of materials. On the left, these are the processes that I run to make this work. So, of course, I set up a Python environment, I install the dependencies, and I run our server that is running here in the middle. After this, I'll be pushing the bill of materials, because I will not be generating them right now live, because it will take a bit of time, because you need, for example, for npm install the requirement, generate the SBOM, it takes time. That's why we have automation on top of this in the company, using Jenkins and GitHub Actions to do this by us. And for this, I'll copy and paste these commands. So this command, what it did, I can show you the files that are in here. So we have Surface, software bill of materials, SCA OSS is a fork of mine that I use to test the merge requests, and also NodeGoat, that is a vulnerable application from OWASP that we can look into. So on this command, I took the file and I sent it to our server with the repository information. This is the way where we'll start grouping the dependencies by projects. We'll link this SBOM with this specific repo. And I have two more of them. So I'll take also this one, and it's the next one, right? No, this one. Let me just check to make sure. Yeah. So all the three of them were created in our database, and I can show you coming here. If I go to the SBOM list, now I have three UID, the identifier for the bill of materials that are in our database. So let me try and show you the information in one. So the path is basically the same, but for a specific one. Of course, this is great. We have a lot of information here, as you can see. And let's go for the dependencies. On the dependencies, we have the main dependencies, the dependencies of that dependency that the software bill of materials generated. We cannot control the output. We generate it using the tool, and then we process the results based on it. And of course, we have the single dependencies and the dependencies of those dependencies. As you can see on the black, then you have a depends on and more dependencies that it brings on when you install the application. And another thing that we do, let's pass it here. Let's pass the parameter vuln data true. This will take a little bit just to load. And now, at this right moment, we took our SPOM, we went to Google OSVDev, and it returned the vulnerabilities. And if I expand them all, and I search for vulnerabilities, there you go. Let's take the first one as an example. This is a vulnerability on Django 3.2.23. And you can see here that it was introduced on Django 3.2, and the fix for this vulnerability was on Django 3.2.25. Of course, this is great. We have dependencies, we have an SPOM, we know what to use, we know the vulnerabilities. Let's take these JSONs and give them to the team for thousands of repos. It can't happen, right? So there's another process on top of this. Now, basically, we'll run so what does this command do? This command goes to our SPOM API, gets all of the data, and puts it in Django models. It's a main dependency model and then a vulnerability models. On the dependency model has a nice thing that is a many-to-many field for itself. So it can be a dependency can have multiple dependencies, and this is the way that we can track the dependency trees. And we run it, and what it's doing is basically querying Google at the same time, because it does the same query that I did, gets the vulnerabilities. The second one takes a little bit of time, or no, the third one takes a little bit of time at this time because it's bigger. So it goes to Google, it gets the vulnerability data, and then you will have the information on your tool side. So we can see on the output 3 software bill of materials were successful process. So far so good. We are okay. And now let's go on the tool view 1. This is what we can show you right now. This was our first iteration. We were so proud of this. And because we could come here, and let's take the example of Django 3.2.23 that is right in here. We can search for it, and we can go right here, open the Django. There's the dependency trees of it, and there's the parent trees that are all the dependencies that use Django 3.2.23. But one thing that we did, because the dependencies are identified based on a package URL for the pearls, and we made our own package URLs. So they are based on the repo itself. This is a way to identify the repo where the dependency is used. So if you search GitHub right here, it will highlight 2 repos where that dependency is present. It doesn't mean it's installed, because if one dependency installs the 3.2.23 and your application is pinned at 3.2.25, the 3.2.25 will be the one that will be remaining in your environment itself. Of course, other than that, we have the findings. This is the dependency findings. We can go for the Django again. And we can see, OK, these are the Django vulnerabilities that it found. We can have more information if we open it about the issue. We have the button to suppress. And OK, this was the first version we put out there. And then, of course, to calculate the risk of that application, we had a recursive mechanism that started from the button until the parent to identify the vulnerabilities. Great. But everyone was saying on the developer that were interested in this, it's not easy to use. How can I use this tool? and then we reach each other. This cannot be as it is. We need something usable. So let's make another iteration of the project. Let's make the V2. And on the V2, we came with one thing that is called SCA projects. The SCA projects view is a view where we aggregate the vulnerabilities per repository. So each one of these package URLs is linked to a repository, as you can see on the repo itself, because each dependency also has a foreign key for another model that we have. It's called Git source, where you put all your Git sources for your applications. If you don't have them in your database, the SBOM, as it has the repo information, it will create the Git source for you. So the Git source will be right there, so you know where the repo is. OK, we have this information, but we keep with the same problem of managing the vulnerabilities and displaying the things that we have as we were supposed to. So we came up with the help of Fomantic UI, another open source tool. It was previous Semantic UI that was stopped, and now it's Fomantic UI maintained by the community. We came up with this view that it helps a lot. It has some nice buttons where you can search for a dependency, and then for this is public. I didn't mention this is public in the presentation, but this is something that we also run after we have all the dependencies to try to help tackling an issue in security that is called dependency confusion. Because we don't have only open source dependencies in our code base. Sometimes you have internal dependencies that are created. And if a hacker can reach that, he can publish on one of the public repos an higher version of that dependency, and that one can be installed in your machine. So at least we try to identify if our internal dependencies that we know are marked as public, because we are basically querying the registries, looking for it, and we have this kind of information from our side. And what about the vulnerabilities view? This is where the things start to look like something. So not sure why it's not in the center, but OK. This is our view for vulnerabilities. And with this view, you can know the vulnerabilities for your repo, for your application directly. It's not only, OK, I know I have a lot of vulnerabilities, but now this is scalable. This is something that you can build automation on top of this and show to the teams. Go into that URL, search for your repository, and you will have your SCA vulnerabilities present. You can see them. And based on this, you can have information about a specific vulnerability. Let's take the Django again. And these are the two vulnerabilities from Django. Of course, we have a mechanism that I mentioned before. It is to suppress. That opens a new view. And of course, you can put a reason, because you need to suppress this for a reason. But there's no way to suppress an issue in our SCA tool without giving a reason and logging the user that made that change, because this is really important for audit purposes. So, and the reason, I need to go to production today. Of course you do. You are a developer. You need your code to work and to be in production. And again, coming to this, if I refresh this page, there you go. We have one Django vulnerability present. The other one is suppressed. Even if it comes in all the same vulnerability comes in other synchronizations, it will be ignored because it was suppressed. But it should have been suppressed for a company reason, not for just because someone wanted to go to production. And going back to the dependencies view, we have this nice button that makes you filter for vulnerabilities. So packages that actually are vulnerable. And we have the counter, so you know which dependencies are vulnerable to what. And on top of this, then we said we have a solution for the guys to renovate the dependencies and to have an upgrade, like a single button you can press. We also have a job that you can configure to the teams for a specific repo to upgrade multiple dependencies at the same time. There's a button to renovate all the dependencies in a repo. And of course, on the vulnerabilities view, there's another one to renovate the vulnerable dependencies. But let's take one as example, just to make sure that our possibilities to fail are a little bit lower. So I will run renovate. On the background, this button should be launching a Docker container that runs renovate, another open source tool that you can use to renovate your dependencies and create a pull request on the repository that will give the developers the possibility to look into the merge request and test it and update the dependency. And right now, if I come to our repo, there we go. We have a major upgrade, so to the latest version of Django in this case, and a minor upgrade to the Django 3.2.25. Do you remember it was in the SBOM as the fixed version for that specific vulnerability? And this is what the tool does. These are the main features of it. And now I will pass give the word to Diogo, that will talk you a little bit about the key takeaways of this work.
So, here's a recap of everything that we've done, the plan for the future iterations, and everything that comes in between. The first thing that I want to tell everyone is that we need some kind of proactively dependency management process in our organizations. It's essential for the large-scale organization and their challenging development environment. So we kind of need to have some kind of an SCA in the company, and we kind of need to be actively managing those dependencies. Otherwise, that will be a mess. You will have we have a security incident, we have a vulnerable dependency. What can we do? The first time, if a company doesn't have an SCA, they will check where this dependency is used on the code and go manually upgrading each one of those. And well, it's an L to do and work like that. You will take some time, the dependency will be there, you have a real-time incident to fix and do the things on that. And you also can have dependencies that are installed from another dependency. Well, that's pretty hard to manage the things like that. And that's what an SCA stands for. And SCA is there and will take that challenge from your side. Our solution actually is free for everyone. You can install the Django SBOM as a pip package. It's on the PyPy and it's pretty funny to use. We can have support for multi-vulnerabilities and end-of-life dependencies. It's easy to implement and set up. We have onboarding guides and the things are pretty much easy, more or less. And we have you get the opportunity to dig into the surface security world. And well, our solution, it's open source, it's out there for everyone. We actually want to call out for other contributors because we think our products are great, we think we delivered a good job, but well, others may not think the same way. And well, it's actually very important to have solutions like this. Important because we actually use a lot of open source stuff and we kind of use it internally on our things and we never give back anything to the community. And it's great to give back a little bit. And well, that's one of the key take points from the solution. And this is what we plan on doing on the future, increase the documentation so it's easier for new persons to go out there and, well, start using the tool itself. We want to have a little bit more governance, like having a public roadmap, future releases, tracking everything done like it should be, not just the plan and project that we put it out there. We can have a little bit of tech debt. We do things differently on several sides. We need to have some kind of standard and, well, probably will have in the future. And the other one is external communication because we need to promote a little bit of the tool, like I said, so that we can get a lot of feedback, we can get other contributors and, well, improve the things in the end. And, well, thank you for being here on the conference. It's actually the point to say thank you for the organization for having us here. And, well, there's a time for questions. That's where the repo is. You also can just look us up on LinkedIn and, well, talk everything. So, well, feel free to take questions now.
So does anybody have any questions they'd like to ask? Hold on, I'll get to you.
I check out the repo and there is no any license. You definitely have to pick one and mention it in the repository.
I think we had some MIT somewhere. Maybe someone removed it, but I think it was some kind of there. But yeah, I'll double check on that. And yeah, that's one thing that it's a little black for us. We just put the things out there, but yeah, we kind of need to have someone looking at it.
Yeah, because it's super important for your open source traction.
Thank you.
Do you maybe have some recommendation for something similar for JavaScript?
For JavaScript. So at this point, the tool and CDXGen is out there, and it can run against JavaScript projects. Basically, what the tool provides is a way for the people to consume what that tool is putting out. We have a JavaScript project in the company. We are scanning those, and we are showing basically what we show to you guys for JavaScript projects. Basically, the coverage for CDXGen, what it covers is what our tool can basically show you, and can sync and can work around it. We are planning also to have coverage for Docker files and its dependencies. We are starting to work on it. It will be there in time. Not sure if it will be really soon, but we are working on it because it's a really blind spot and something that we really want also to show to the guys and to the people that use the tool.
Any more questions?
It's not really a question, but I'm really intrigued by this because I'm doing my talk later is on threat modeling, and I'm always looking for a way to help the developers to, yes, threat model the design, but threat modeling the SBOM. This just opened up a whole. I'm going to have to copy some of your slides and put them in my talk.
It's completely okay. We can discuss this later, of course. So there are no more questions. Thank you guys for having us. It was actually our first conference, our first presentation, and this was the most recent tool that we built. So thank you all. I hope you enjoyed.